So here I'm presenting my how do you call it? My ONG. So we are called PDNA, or Pathogen Genomic Diversity Network Africa. This is an independent, not-for-profit African-led scientific association. And most of us are specialized in genomics, genetics, molecular biologies, and bioinformatics. And our goal is to generate data, analyze, utilize those data to improve human health in Africa. And we are present in 16 African countries, including Mali, Nigeria, Ghana, Ivory Coast, Gabon, etc. We also do trainings. For example, we train NMPC for using molecular tools how to analyze and detect malaria. My research activities are mainly focused on malaria, and then currently we are doing a national-wide research. So we are working with at least 70 centers, health centers, and then we are looking at the deletion of a gene which is involved within the diagnostic of malaria. And then from those who are working on malaria, they might know, even for everyone, when we get sick and then we go to a health center, they will do a first analysis. This is done using an RDT that we call rapid diagnostic test. And then most of the tests are based on Plasmodium falciparum histidine-rich protein 2 or 3. And then currently we know that there have been reports with a presence of deletion of that gene, which could cause to a false result, false negative, even though you might have malaria. So it's, in addition to that, we are doing also some genomic analysis to find out about the resistance gene. And beside malaria, I'm also working on antimicrobial resistance, AMR genes. And currently, this is also becoming a very huge issue in human health, not only in Africa, but in the world. And we are looking at those genes that are involved in antibiotic resistance. To do that, we are using next generation sequencing, which enables us to identify non-resistant gene, but also predict one. And then here I have an example of what we have been doing. We have sequenced around 6 bacteria, and then we have found some resistance gene against the third generation antibiotics, which is pretty scary because currently people are misusing and overusing antibiotics just because they have diarrhea or they have other type of disease, but some of them are not working. And then we also identify other type of resistance gene which are linked with cancer treatment and so on. So really ask us to talk a little bit about gene editing. Now I'm switching to plant health, which I'm comfortable with. So this is an example of plant pathogen, Xanthomonas oryzae, Patova oryzae, and it's caused bacterial leaf disease on rice. And the reason why I chose this is that I know Nigeria is #1 in West Africa production of rice, and then Mali is #2. So we eat rice, we love rice, but we have this disease which can cause up to 50% yield loss. So it's pretty interesting, and then it's present everywhere where rice is growing. As you can see here in Asia, Africa, America, so on. So what I did when I was working with my former team is to generate edited lines of rice. We use CRISPR-Cas, but I'm not going to go through that. I think my colleague will do that for us. So we try to look at susceptible genes that are present, which are induced by the bacteria to cause a disease. We use CRISPR to modify those genes, and then we generate some lines. As we were saying, we cannot say these products are 100% safe, but what we do every time we generate some new lines, you have to do some sequencing to look at the presence of PDNA, and you also have to see whether there is off target, we call it, and then you look at the tray of interest as well. That's something we have to deal with, and then you have to make sure every single generation you have to screen them to make sure there is no more TDNA present in there, and so on. So for science communication, since I'm working on human health, and then we know we have issues with malaria and also antimicrobial resistance, we also do some social study to raise awareness about antibiotics overuse and misuse. And then to do that, we involved health practitioner and also the community, because even though we have our result, we know it's very dangerous to be using this, because we have a resistance against almost every single antibiotics we know that we are using in Mali. But if we do not involve them, they might not know, and then they will continue to use those even though they are not really effective, because at the end they might just wait for death. And then for scientific communication, we do also have a lab meeting once a week, and then during those lab meetings, sometimes we talk about our issues. We talk about what is going on in lab, our problems, and then with even our community, what we can do to improve that. And then sometimes we talk about collaborations as well with other labs. And for scientific communication with challenge, I've been thinking myself, I don't know exactly, because I'm not into communication, so I'm always in lab. I don't know exactly what is going on, but we have a good team that is working with us. And all I can think about is we should, in science, we have to try our best to avoid using professional terms, because sometimes when we are having meetings with other people, they just look at us, they don't know exactly what we are talking, but we will just keep talking for more than 1 hour, and then later they will say, can you go back? I didn't understand what you were talking about. So this is something we should think about whenever we are doing scientific communication. Okay, I think this is my last slide. For recommendations, I will say we have to involve other social science and then also stakeholders. And then we also have to change our behavior. To do that, what we did a month ago is to have committees to talk about the community, about the dangers, about using antibiotics and so on. So last, I said information must be delivered in a way that is useful and understandable to those that are not from our community. That's it. Merci.